Hi, this video is about the converse of the Pythagorean theorem. And to go forward, you need to know what the Pythagorean theorem is, and I'm going to assume that you do. And that's the old a squared plus b squared equals c squared, having to do with a right triangle. So just kind of quick review. The biggest mistake people make is that they just kind of always think that the last side mentioned is the hypotenuse, and it's not. First, you have to have a right triangle, and we know that if you know two of the three sides, you can find the third. So just kind of keep in mind that the largest side is always your hypotenuse. So sometimes you might get something listed like this, 3, 4, 5, but you're lucky if the last side mentioned happens to be the hypotenuse. But you really want to do a circle or thinking about the biggest side. And it is a right triangle if the square of one side plus the square of the other side, and we call those legs if it's a right triangle, if they equal the square of the hypotenuse. Well, what we're going to talk about today is the converse of the Pythagorean theorem, which really says that if the squares of the sides, the sum of the squares of the sides equal the square of the hypotenuse, it is a right triangle. It really refers to determining whether that third side is a hypotenuse. So let's take a look. Really, the big question is this: is it a hypotenuse? And I like to think of the whole thing as just focusing on that biggest side. And when you focus on the biggest side, the whole thing, I think, becomes a lot easier. What you do is, first of all, you don't always get a triangle picture. You just usually get three sides. But what you want to do is you take your three numbers. So let's say I didn't get the picture. I just got the numbers 3, 6, and 4. I want to circle or know which one is the biggest side or the biggest length, and that's going to be the 6, of course. And that's the one that I'm going to put on one side of the equal sign by itself, and I'm going to put the other two on the other side and square them and add them up. Now, some people don't actually put an equal sign there. They'll put an equal sign with a question mark over it or a box, because at this point we really don't know if the squares of the two smaller sides do equal the square of the larger side. So that's really what we're trying to find out. So in this particular case, if I do 3 squared, I get 9. If I do 4 squared, I get 16. And when I add those two together, I get 25. Well, when I square 6, I get 36. And they definitely do not equal each other. So it's really improper to put it in an equal sign between them. They're really an inequality. But usually the question, well, sometimes the question is it a right triangle? And this is very easy to answer. The answer would be definitely not. It's no. But sometimes the question is it a right triangle? Is it obtuse, or is it acute? And then you also might be asked, is it impossible? And we'll talk about that in a second. But basically, once I know that it's not a right triangle, I really want to be thinking about this other side, the side that's 6. And think about what would happen. Let's start with something that I know is a right triangle. And I'm going to use a 3, 4, 5. This is kind of a famous proportion for a right triangle. That is a right triangle. What's going to happen if I make this a little bigger? Let's just say I make it like 5.00001. Well, when I square that number, it's going to be just a little bit more than 25. And when I compare it, the square of this to the square of 3 plus 4, which originally was 25, because 3 squared is 9, and 4 squared is 16. We just did it up here. I get 9 plus 16, or 25. Well, the minute I make this a little bit bigger than 5, it's too big to be a hypotenuse, but I have an inequality. So if you focus on that, basically the rules become a little simpler. So let's take a look at the rules. Okay, is the biggest side a hypotenuse? If your biggest side, well, I'm just going to put the biggest side first because that's the one we should always be thinking about first. So if the biggest side is equal to the other two sides, I'm going to just call this c squared. If that's equal to b squared plus a squared, or a squared plus b squared, if it's equal, it's a right triangle. Okay? If it's bigger, okay, and we're just going to call c squared the biggest side. If it's bigger, that means it's obtuse. That means that these two other littler sides have to open up just a little more because the square of that third side, or the biggest side, is more than the squares, or the sum of the squares of the two smaller sides. That means that you have an obtuse triangle. If it's smaller, or less than, this is the less than symbol, the other two, that means that it's a little bit less. And in the case I just had, I did a 3 and a 4 and a 5.0001. Well, what if I had a 3 and a 4 and a 4.99, just a little bit less than 5? What's going to happen is that this angle that originally had been a 90, well, these two sides, the 4 and the 3, have to close up just a little bit more, so this angle is going to shrink, and it's going to make it a little bit smaller than 90. You are going to end up with an acute triangle. I'm sorry, an acute angle there, which makes it an acute triangle. These are basically the three rules. Focus on your largest side, square it, square the other two sides and add them together, and then compare the numbers. But think about, just focus on the biggest side. And if it's equal, it's right. If it's bigger, it's obtuse. If it's smaller, it's acute. Well, let's try some examples. Okay, here we go. We got a 10, a 5, and a 7. Well, I'm going to take the 10. I'm going to square it. That's 100. I'm going to compare it to my 5 squared plus my 7 squared. And I'm going to write that out. I'm going to have 25 plus 49, and I get 74. So when I compare this largest side, and its square, to the sum of the square of the other two, I find that this largest side is actually bigger than the sum of the square of the other two. And that makes that triangle obtuse. Okay, let's try it a few more. I've got a 6, an 8, and a 7. Now remember, the first thing I need to do is focus on the one that's the biggest, and that's the 8. So I'm going to do my 8 squared. I'm going to compare it. You can put a little box there for the symbol. That's my comparison symbol to my 6 squared plus my 7 squared. Well, 8 squared is 64. 6 squared is 36. 7 squared is 49. I want to add those two together. 36 plus 49, I get 85. Ah, okay, well in this case, that largest side is actually, when I square it, it's smaller than the sum of the squares of the other two. And that makes this triangle acute. All right. Notice I didn't even really have to draw a triangle. Sometimes it's helpful to sketch it, but you really don't need to do that. Here I've got a 20, a 30, and a 40. Well, in this particular case, 40 is my biggest side, so I'm going to square it first. That's going to go over here. I'm going to compare it to 20 squared plus 30 squared. All right, well, 40 squared is 1600, and 20 squared is 400, and 30 squared is 900. And when I add those two together, I get a nice 1300. Okay, well, I have 1600 compared to 1300. This largest side is larger than the sum of the squares of the other two. That makes that triangle obtuse. Okay, let's try another one. I've got a 16, a 20, and a 12. Well, my largest one is my 20, so I'm going to square that one first. 20 squared. I'm going to compare it to the other two sides. That's my 12 squared plus my 16 squared. Let's go ahead and do this. 20 squared is 400. You certainly want to have a calculator for these. 12 squared is 144. And my 16 squared is 256. Okay? If I add those two together, I get 400. Well, when I compare the two, I get an equality. Well, that means that this particular one is a right triangle. Pretty straightforward. I just think just make sure you're always focusing on the big one. I consider it to have all the power. If when you square it, it's bigger than the square of the other two, that makes the whole triangle obtuse, because the two arms or the two legs have to open up to make a wider triangle. Thank you for watching.